Which of these two states has a higher entropy? The answer might surprise you, especially if you were told that entropy was a measure of disorder. But first, to make sure that we're all on the same page, we should quickly talk about what macro and micro states are. For example, 5 marbles on the left defines a macro state. It's an abstract definition that does not exactly specify the position of each marble. And there are a lot of marble arrangements that fit this macro state definition. And we call these underlying, precisely defined arrangements microstates. Here you can see all the possibilities how we can arrange 9 marbles on this grid, ordered by how many of them are on the left side. From all 9 marbles on the left, over 8 marbles on the left, and so on, all the way to no marbles on the left. Now, entropy measures how many microstates belong to a macro state. For example, the 5 marbles on the left state has a high entropy because it contains a lot of microstates, while, for example, the 9 marbles on the left macro state has a very low entropy because it contains only one microstate. Only one arrangement of marbles fits this description. Now, back to the original question. These two states are both microstates. They are both just one microstate, so they have the same entropy, an entropy of 0 in fact. This state might look special to us, but it's actually not any less likely compared to any other microstate of the system. If I shake this again, it would be just as unexpected to exactly get this state again as it would be to get all marbles on the left. Nature doesn't care how ordered or disordered a microstate might look to us. They all occur with the same probability. The only reason why a macrostate like 5 marbles on the left has a high entropy and is likely to occur is because it's a loose abstract definition, and in making it I have lumped together a lot of microstates. And this reveals a very interesting fact about entropy. Entropy is not a physical property of the fundamental microscopic reality out there, like for example mass or energy. Instead, it only emerges from the abstractions and the simplifications that we introduce to the world around us. A gas at volume V and temperature T is another example for such a very abstract definition of a state. We have abstracted away all the atom positions, all the velocities, and in only specifying these abstract variables like temperature and volume, we lump together lots and lots of microstates, just like we do in the 5 marbles on the left case. And that's why entropy plays such a big role if we deal with states of gases or other matter as we typically do in thermodynamics. But isn't that kind of weird? Entropy appears to be this quantity that governs the evolution of all processes. Everything seems to evolve towards high entropy. And ultimately, scientists predict this inevitable heat death of the universe, a state of the universe where it has reached its maximum entropy, a state where we no longer have hot stars and cold planets, but just one giant dull mixed soup of matter. But how is that possible? That entropy seems to govern stuff, seems to have very real consequences, when at the same time it's also just an artifact of how we look at the world, and it solely depends on which variables we pick to describe the world. Now, this might sound weird, but actually fortune tellers can help us to resolve this apparent contradiction. A fortune teller, of course, has no idea what the future might bring. Instead, they make very clever use of the principle of maximum entropy. They would never say something like, tomorrow at 9:32, a seagull will relieve itself onto your left shoulder. That's way too specific. Only very few of the microstates the universe could be in tomorrow would fit that description. Instead, they would go for the high entropy stuff. Say something abstract like, I see a shadow. Something bad is going to happen. Could be that damn bird. It could be any bird at any time, or you just ran out of coffee or whatever. Something bad happens all the time. Almost any possible future microstate of the universe fits that description. Now, if physicists predict the heat death of the universe, they do pretty much exactly what any fortune teller does. Of course, they have no idea in which exact microstate the universe is going to be in billions of years. If they made a prediction like all atoms are going to be neatly sorted according to their size, only very few of the possible microstates would fit that prediction. They would almost certainly end up being wrong. It makes much more sense to make a high entropy prediction, something that's so unspecific that the overwhelming majority of possible microstates fits that prediction. And that's how we end up predicting the heat death of the universe turning into this arbitrarily mixed soup of atoms, a prediction that fits so many microstates it's almost guaranteed to come true. It's not like there's some mystical force pulling the universe towards high entropy. On a microscopic level, entropy doesn't even exist. Atoms just bump into each other, they do what they're doing, and if you give them enough time, all possible microstates occur with the same probability. On an abstract, macroscopic level, however, with the lack of knowledge what's exactly going on beneath, we are forced to guess what's going on. And given the limited knowledge we have, the maximum entropy guess, the one that lumps together the most microstates, is the one that's most likely to turn out right. In a sense, it's a bit of a trickery though, isn't it? If we maximize entropy in a prediction, rather than really predicting anything, we are instead carefully crafting a statement that contains the least amount of information. We are choosing the prediction that says the least about the future. For example, if I am predicting that at least one marble is going to be on the right, I'm providing almost no information about the future. I'm just ruling out a single of all possible microstates. And of course, I end up right. If fortune tellers predict that something bad is going to happen, of course they are right. Something bad happens all the time. That's also a prediction with almost no information. And if physicists predict the heat death of the universe, it's the same thing. Of course, the universe is going to turn into some arbitrarily mixed soup of matter. This statement is so broad, almost any possible microstate fits that prediction. Maximizing entropy, in a sense, is a tool to identify the obvious, a tool to identify the statements that are essentially guaranteed to be true because they hardly say anything, because they hardly contain any information in the first place. Now, maybe this makes it sound bad. We generate statements that are true because they hardly say anything. And it's really a bit weird if you think about it. But on the other hand, what could be more important than to at least get the obvious things right, to identify the things that are almost guaranteed to be true?